What is shank? The main body of the cutting tool and is also part of the tool that is gripped in the tool holder or tool post. The main function of the tool shank. Face is top surface of the tool over which the chip flows during the cutting. At the time of the cutting, the chip is flowing through the face. And cutting edge. What is cutting edge? The cutting edge of the portion of the face edge and separate of the chip from the workpiece. The cutting edge of the tool includes in the end cutting edge and side cutting edge. You can see side cutting edge this one. So this one is the end cutting edge. End cutting edge means it is the cutting edge formed at the end face of the tool. End face of the tool. Side cutting edge means it is the cutting edge of the tool, side face of the tool. Side face of the tool and end face of the tool. And next one we can take, this is a plank. What is plank? Plank, it is a surface adjacent to the tool and below the cutting edge, and the tool lies in horizontal position. The tool lies in a horizontal position. So what is the nose? Nose means we can see this figure clearly understand. So nose, it is a tip of the cutting tool and formed by the interaction of the side cutting edge and the end cutting edge. Interaction of the side cutting edge and end cutting edge. And last one is a nose radius. It is the radius of the nose of the cutting tool. First point. The nose radius is very important parameter since it gives strength to the cutting tip, increase the tool life, and give fine surface finish on the workpiece. The value of the nose radius is ranges from 0.4 to 1.6 mm, standard value, and depends on the several factors like depth of cut, amount of feed, type of tool, etc. So this is discussing about the single point cutting tool nomenclature. Next, geometry of the single point cutting tool: side view, top view, and front view. You can see that is a. So this is the angle between these two lines. It is called as a lip. This one is a base. This one is a shank. This one is a base. So end lip angle. So this angle and lip angle. This is a top view. Side view, front view. Front view you can get nose radius. And this one is top view. This one is a top view. Nose radius, base and shank, and cutting edge angle, side cutting edge angle. So the front view, that's a side. Single point cutting tool, front, top and side. So you can see this figure clearly. This is a single point cutting tool. Already different elements or different names parts will be explained already. So these two figures are very important in single point cutting tool nomenclature. Cutting tool nomenclature. What is the tool shank? I already explained. The main body of the cutting tool that grips the tool holder. Face is the top of the surface of the tool over which the chip flows during the cutting. So cutting edge, there are two important: side cutting edge angle and end cutting edge angle. The top portion of the face and edge that separate the chip from the workpiece. Side cutting edge is the primary or major cutting edge from the side face of the tool. End cutting edge, it is a minor cutting edge formed at the end cutting edge of the end face of the tool. Plank, the surface adjacent to below cutting edge and the tool lies in horizontal position. The tip of the cutting tool and is formed by interaction of the side cutting edge and end cutting edge. And nose radius, it is very important geometric parameter since it gives the strength and cutting, it increases the tool life, gives the fine surface finish of the workpiece. The nose radius range from 0.4 to 1.6 mm, depends on the depth of cut and feed and type of tool. Value of nose radius increase, the tool life will be improved. The tool life will improve. So next one you can go for this tool shank, face, cutting edge. One is rake angle. There are three important rake angles. Rake angle is, there are three important rake angles. The first one is a zero rake angle, and the second one is a positive rake angle, third one is a. Next three important types of rake angle: zero, positive and negative. So angle, rake angle. So first is zero. So you can see the figure number 1, figure number 2, figure number 3. The first figure that indicates for the zero rake angle. Second one is a positive rake angle. Third one is a negative rake angle. So zero rake angle or neutral rake angle, both are same, zero rake angle or neutral rake angle. So in this case, it increases the strength of the tool and prevents the cutting edges of the digging into the workpiece. So zero rake angle is not used in metal cutting operation. Zero rake angle, it is not used in the metal cutting operation. This is very important. So the metal forming tools are provided with a in forming process used for the zero rake angle tool. In a forming process, next you can study the unit number 4 and 5, the forming process. So zero rake angle tool, it is used for the metal forming process. And positive rake angle, you can see this is a positive rake angle. It helps to in formation of the continuous chip in ductile material. It is a help or it is a use. Continuous is avoiding the formation of the built-up edge of the chip. Used of cutting tool, non-ferrous and low tensile strength material. And for machining hard metals, tools are given smaller rake angle, and soft material, longer rake angle. So next one is the negative rake angle. The tool with the negative rake angle are stronger and make them suitable for machining high strength material. Generally employed on carbide equipped tools for machining extra hard surfaces, harder steel parts, cast steel. To increase the negative rake angle leads to increase the cutting force during the machining, which in turn causes vibration and increase the working. So these are the three important types of rake angles used in the. So the cutting tool nomenclature. What is the cutting tool nomenclature? Cutting tool nomenclature. So in cutting tool nomenclature, back rake angle, side rake angle, different parts are different designated the names, standard names. Back rake angle, side rake angle, end relief angle, side relief angle, end cutting edge angle, side cutting edge angle, lift angle. So these are the cutting tool nomenclature. So back rake angle measures the downward slope of the top surface of the tool from tip of the tool nose to the rear along the longitudinal axis, that is z-axis. Back rake angle can be positive or negative type. It allows the chip to flow smoothly when the material is cut primary and cutting edges. And second important, side cutting edge. And second important point is side rake angle measures the slope of the top of the surface of the tool to the side in direction perpendicular to the longitudinal axis, z-axis. Side rake angle can be positive or negative. It allows the chip to flow smoothly when the material cut by the side cutting edge. So end relief angle means it is an angle between the plane perpendicular to the base of the end plank of the tool. End relief angle prevents the end of the cutting tool rubbing against the job during the machining process. So side relief angle means it is an angle made by the plank of the tool and the line perpendicular to the base just under the side of the cutting edge. Side relief angle permits the tool to feed the sideways into the job so that it can cut without rubbing against the job. End cutting edge angle means it is an angle between the end cutting edge and perpendicular to the tool shank. It acts as a relief angle by followed only a small section of the cutting edge to participate in the cutting action, thereby preventing character and progression. And last but one, the cutting edge angle. It is the angle between the side cutting edge angle and the horizontal axis of the tool. It avoids the formation of a built-up edge, control the direction of the chip flow, and distribute the cutting force and heat produced over a longer cutting edge. And last, slip angle. It is an angle between the tool face and the ground end surface of the plank. Lip angle is maximum when the clearance of the rake angle are minimum. The larger lip angle, the stronger will be the cutting edge. So you can see this figure clearly understand. So this is a face, radius, all these are studied in last slide. So this is very important. This is the cutting tool nomenclature. Designation of the cutting tool is also very important. So designate. What is designation of the cutting tool? It denotes the standard system specifying the principal tool, angle point cutting tool instead of as tool signature or designation. So ASA, American Standard Association System, or ANSI, American National Standard Institute, the tool angles are specified independently of the position of the cutting edge. The three planes reference and coordinates are chosen based on the configuration axis of the machining tool concerned, x-axis, y-axis and z-axis. So there are seven important elements cutting tool. There are seven elements denotes the single point cutting tool. In the are as follows: 10, 9, 6, 5, 8, 7, and 2 degrees. 10, 9 degrees. So the back rake angle is to be maximum 10 degree, side rake angle 9 degree, end lip angle 6, side lip angle 5, and cutting edge angle 8, and side cutting edge angle 7 degree, and nose radius is 2 mm. Except nose radius, all are in angles, degrees, and last radius is in mm. So these are the seven important points. It is called as a tool geometry or designation of the cutting tool. Very important. Sometimes also tool geometry also. Tool geometry means the cutting should be provides the best results in any situations or conditions during the machining. Okay, the tool is designated denoted by a standard system. This is a standard system. Seven important elements: 10, 9, 6, 5, 8, 7, and 2 mm. So this is a tool signature or designation of the cutting tool. Designation of the cutting tool, ORS. ORS means orthogonal. There are two important. There are orthogonal rake system and oblique rake system. So in orthogonal rake system, the tool angles specified by reference to the position of the cutting edge. Second point, the planes of the reference and coordinations are chosen based on the configuration of the cutting tool. And third one is a seven elements denotes by single point, same angle of inclination, normal rake angle, side lip angle, and cutting edge angle, approach of the angle, and nose radius. So this is a ORS rake system. Next we can go for this is about the only discussing about the single point cutting tool completely. Single point cutting tool, properties and materials, and this one geometry, single point, rake angles, different type of zero rake angle, positive rake angle, negative rake angle, and tool signature or tool geometry. Next we can same thing as you have to study about, just you can remember. So main parts of the drill bit is a multi-point cutting tool. This is the cutting edges. These are the cutting edges. It acts as a more than 1 point, 1, 2, 3, 4. That's why it is called as multi-point cutting tool. Cutting edges is more than one. So the main parts of this drill bit or drill tool. So drill point. This one is not a drill cut. This is a drill point. This one, and dead center. Drill point of dead center. Body, shank, helix angle, and flutes. These are the important parts of the drilling machine. Important parts of the drilling machine. Drilling tool or drilling cutter. Cutting fluids. It was so simple. At the time of the cutting, the anomality is developed between the workpiece and tool. The cutting fluids are used during the metal cutting. The cutting tools is slides on the workpiece. Material heat generated due to the friction between the tool and the workpiece. The excessive heat generated can damage the microstructure of the both cutting tool as well as workpiece. Also, life of the cutting tool reduce the higher temperature. In order to reduce the friction and heat generated, cutting fluids are used. So use right kind of cutting fluids improves the machining operation. So function of the cutting fluid. What is the function? To cool the cutting tool and workpiece, to reduce the friction between the workpiece and tool, to provide the lubrication between the tool and workpiece, to carry the away from the chip, to improve the surface finish, to prevent the work against the rusting, and prevents the adhesion of the chips of the tool or workpiece. Requirement of the cutting fluids. So it should have good lubricant qualities. It should have non-positions and should not cause the skin irritations. It should have high thermal conductivity at high specific heat. It should have not stick workpiece on the tool or machine. During the use of it, will not produce the fog and smoke. It should have flow easily and over the entire cutting area. It should be suitable for heavy variety of the cutting tools and material and the cutting operation. It should have longer life, free of excessive oxide formation. It should have easy to separate from the requirement and chip. Types of cutting fluids used in the industry: oil-based and fluids. In that there are two subclassified. First one is a straight oil, and second one is a soluble oil. So next is the chemical fluids. There are synthetic fluid and semi-synthetic fluids. So details about the straight oils. These fluids are minimum. These fluids are minimum, and this one is. So next we can study about the dedicated straight oil. What is straight oil? So these fluids are mineral oil based. First, it is very important. These fluids are mineral oil based. They contain no water. Metalworking functionality of straight oil may be improved by various additives. So various additives means fatty oil for better wettability, sulfur, chloride, and phosphorus for extra pressure conditions and better lubrication. The advantage of a straight oil, the main advantage is excellent lubrication. First one. Second one is a good corrosion protection, easy maintenance. And the drawbacks for this straight oil: poor heat removal rate, toxic and high viscosity, flammable and expensive. These are the drawbacks. And straight oils are usually in a low speed application for metalworking, stainless steel and other poorly machinable metal, and in the operations in which good lubrication is necessary, honing process or deep and drilling process, etc. Second one is soluble oils. Soluble oil is also referred to as water soluble oils. Soluble oils are mineral oil providing stable, finally dispersed oil emulsion in water. Oil mixed with water and concentration about 2 to 10%. And main advantage of this soluble oils: the good lubrication, first one. Second one is good cooling capability and some corrosion protection and low cost, non-flammable. So these disadvantages or drawbacks for this soluble oil: antibacterial additives and maintenance are needed, toxic. So these are the drawbacks for the soluble oils. So next we can go for the synthetic oil or fluids. Synthetics are water-based solution for synthetic lubricants, corrosion inhibitors, water softeners, antibacterial additives, and glycols and other additives. So second important point is the synthetic fluids are supplied from the concentrate which are mixed with water before use. The advantage of this synthetic fluids: very good cooling capability, first one. Second one is a good lubrication properties. Third one is a good stability in hard water, good corrosion protection, and easy handling. Then last one is cleaning and maintenance. Drawbacks or disadvantages of this synthetic fluids are some toxicity, easily contaminated for the virgin oils, relatively high cost. These are the drawbacks. Next one is synthetic fluids are used in a wide variety of metalworking or metalworking operations, including poor machining alloys, have heavy duty grinding and high speed cutting. Can use that synthetic fluids. Semi-synthetic fluids are water-based mixer or synthetic lubricants, additives, emulsifiers, and some amount 2 to 30% of the mineral oil. Advantages: they process better corrosion reduction than synthetic fluids and better cooling and weighting capabilities, easier handling and maintenance the mineral emulsion. Drawbacks: listing relatively poor stability in hard water and contaminated by fluorine oils and some toxins. Selection of the cutting fluids. On what basis you have to select the cutting fluid? Following are the important factors to be considered before selecting the cutting fluids. Selecting the cutting fluids for the particular application. First one is the cutting tool material. Which type of material you can use to prepare the tool, and workpiece material, the types of material, whether it is ferrous or non-ferrous, or then we have to study. Type of machining process, which type of machining done on that workpiece, that is very important. Viscosity of the fluid and machine conditions, human interaction at cost, and color and smell, etc. So these are the important cutting fluids. On that basis, you have to select the cutting fluid. It's very important. Methods of applications of the cutting fluids: mist and food and jet.